This is the second in a series of videos around making a circuit board using a CNC mill and a few other techniques. If you haven't seen episode 1, there is a link below in the description. In that video, I covered the purpose of the board, I shared the design in Fusion 360, laid out the gear that I'm using including the drills and cutting tools, and shared the first operations performed on the board. If you are following along with this series and you're enjoying it, please like, subscribe, comment, or forward to your friends. I should note, CNC milling in general is dangerous. Please remember that if you choose to follow along with this video, you do so at your own risk. In this video, we'll go through the various drilling operations. There will be 4 in total. First will be the spot drill, to help the other drills align properly when drilling through the PCB and not deflect off center. Then, we'll cut the 2.5mm reference holes. Third, we'll drill the 3.5mm conductor holes. And finally, we'll drill the 1mm component holes. Okay, let's jump right into it. Starting out with the spot, I want to make sure that I put a pilot divot wherever we're going to be drilling. Here are my feeds and speeds for this operation. Now we move into the full drill-through operation to make the reference holes. I used the standard drilling operation in Fusion 360 with Rapid Out, and here are the feeds and speeds for this operation. As I mentioned in episode 1, these will be used to maintain our reference point on the wasteboard when flipping the boards and milling the back side, so I'm drilling these especially deep to make sure the wasteboard has good holes to align into. I'll use the reference holes when flipping by using some 2.5mm pins I bought in a set on Amazon. There's a link below in the description if you're interested in getting them. They are very useful for this sort of technique. Next, we're drilling the 3.5mm conductor holes. I will again use a standard drilling operation with Rapid Out in making this, and here are the feeds and speeds. This is where we will actually solder in wire to bring current to the board. Finally, the 1mm component holes, where we'll solder the additional components on the board. In this operation, the drill is quite thin, and I was concerned about a standard drilling operation being a bit too hard on that drill bit, so I've used some deep drilling technique instead. This is similar to chip breaking in that it will plunge up and down in short intervals as it goes through, but the difference is that at intervals it will pull out completely. Here are the feeds and speeds that I used. And there you have it, our holes are drilled. In my next video, I'll be sharing the adaptive clearing operation that will remove the bulk of the copper on the top side of the board. Stay tuned! If you liked this video, give me a thumbs up, subscribe, click the bell, or leave me a comment below. And as always, happy making!